This series of videotaped programs is designed to increase your knowledge of aircraft maintenance. This program is part of an integrated training series produced by Aviation Maintenance Publishers. Aviation Maintenance Publishers is dedicated to professionalism in the education and training of aviation maintenance technicians.
The safety record of modern air transportation is superior to most other popular forms of transportation. Two important factors that influence that safety record are the amount of weight an aircraft carries and how that weight is distributed. The importance of weight and balance cannot be overemphasized. In this program, you'll learn the principles upon which aircraft weight and balance calculations are based. Every object has a point at which all of the weight of the object is considered to be concentrated. This is the balance point, or center of gravity of the object. The center of gravity, or CG, is often identified by this symbol. If an object is suspended from this point, it will remain in balance. Adding weight to any part of the object will cause the object to rotate. To balance the object, either a new balance point must be found, or weight must be added at some other point on the object. Adding too much weight, though, could overload the object or its support with predictable consequences. Aircraft are designed to carry a maximum amount of weight. This maximum, or gross weight limit, may be found in the aircraft type certificate data sheets, aircraft specifications, or aircraft listings. These are Federal Aviation Administration documents, one of which is issued for every aircraft certified in the United States. Overloading the aircraft beyond the gross weight limitations may place dangerous stresses on the structure, especially in rough air or during a hard landing. Aircraft are also designed so that their center of gravity may shift in a narrowly defined range to accommodate various loading configurations. This center of gravity range, or CG range, is also shown in the aircraft certification documents. Loading the aircraft so that the center of gravity shifts outside of this range may cause serious control problems and may seriously affect the stall characteristics of the aircraft. Pilots are required by law to know the weight of their aircraft and its loading conditions before beginning each flight. The aviation maintenance technician must also be aware of the weight and balance requirements of the aircraft on which equipment may be changed, moved, or replaced. Many light aircraft are designed so that exceeding the weight and balance limits is difficult to do accidentally. Fuel tanks are located in the wings at or near the center of gravity. Passenger and crew seating is also located at or near the center of gravity. And baggage compartments are also near the center of gravity, with limits posted as to the amount of baggage that may be carried. Some aircraft, on the other hand, may be loaded so the center of gravity may easily be shifted outside of the specified range. Passengers in this aircraft could be seated well aft of the specified center of gravity range. Larger cabin class aircraft have several possible loading configurations which require the use of special loading charts. The empty weight is the weight of the airframe engine, fixed operating equipment, unusable fuel, hydraulic and other fluids necessary for flight, fixed ballast, and full oil on aircraft certified after March 1st, 1978. Aircraft certified before March 1st, 1978 include only undrainable oil in the empty weight. Undrainable oil is that oil which cannot be drained by removing the drain plug with the aircraft in normal ground attitude. The difference between the empty weight of the aircraft and its maximum gross weight is its useful load. This is the allowable weight of all fuel, passengers, cargo, crew, and all additional equipment not included in the empty weight. Whenever new equipment is added, or old equipment relocated or removed from the aircraft, a record must be made so that weight and balance records may be kept up to date. Aircraft used for carrying passengers and cargo for hire must be reweighed periodically, and the center of gravity must be recomputed. The principles involved in computing weight and balance should already be familiar to you. They are basic principles of physics using levers. A lever is a simple machine by which a force acting on an arm produces a moment which tends to rotate the arm about a fulcrum. A weight placed at the other end of the lever at a certain distance from the fulcrum will balance the lever with another moment. The arm on the right or aft of the balance point is assigned a positive value, while the arm on the left or forward of the balance point is negative. When the algebraic sum of the moments is 0, the lever is balanced. A teeter-totter is a good example of this principle. A heavy weight a short distance from the fulcrum, or balance point, will balance a light weight at a further distance on the opposite side of the balance point. Here we already know where the balance point is located, but suppose we didn't have this information. We would have to measure the distance from the weights to a reference point to be able to find the balance point. This reference is called the datum and may be located anywhere. In our teeter-totter example, the datum was assumed to be located at the balance point. All measurements were made from this line. We could just as well have located the datum at the center of one of the weights. Here we have a 25-pound weight on the datum and another weight of 50 pounds 12 feet to the right of the datum. Since the 25-pound weight is on the datum, the arm is 0 and the moment is also 0. The 50-pound weight is acting on a 12-foot arm to the right of the datum, a positive 12-foot arm. Multiplying the weight times the arm yields a positive moment of 600 pound-feet. The total weight on the lever is 75 pounds. Dividing the total moment by the total weight yields the balance point, a positive 8 feet, or 8 feet to the right of the datum. Aircraft manufacturers may locate the datum anywhere on or off the aircraft. The location of the datum for a particular aircraft is given in the aircraft's certification documents. Common locations for datums are the firewall, the tip of the propeller spinner, and at a specified distance ahead of the aircraft. It should be emphasized that the datum is only a reference and may be located anywhere the manufacturer decides. Each piece of equipment, each compartment, and the point at which all of the weight of the aircraft is concentrated, the center of gravity, are all located at a specified distance from the datum. These distances are expressed in inches and are shown in the data sheets as station numbers. Station number 42 is 42 inches from the datum. Station numbers ahead of the datum are given a negative sign, and those aft of the datum are given a positive sign. Before making any weight and balance calculations, make a simple chart with lines for each item in the problem and columns for the weight, the arm, or the distance from the datum, and the moment for each item. Aircraft are normally weighed with scales at the center line of each wheel or at specified weighing points. These points are located by station number. In this example, the weight on the left main landing gear is 617 pounds and on the right main 614 pounds. Both main wheels are located 68 inches aft of the datum. The weight on the nose wheel is 155 pounds and is located 26 inches ahead of the datum. Multiplying the weight of each item by its arm gives us the moment for each item. Notice that the moment of the nose wheel is negative. Add the weights of each item to get the total weight of the aircraft. Add the positive moments and subtract the negative moment to arrive at the total moment. Divide the total moment by the total weight to find the center of gravity. Locating the datum at the tip of the spinner allows the use of all positive arms and moments, since all points on the aircraft will be located to the right of the datum. Again, organize a weight and balance chart with lines and columns for all of the information and fill in the known information. The nose wheel is 34 inches aft of the datum. The main wheels are 139 inches aft of the datum. The weight on the left main is 617 pounds, on the right main 614 pounds, and on the nose wheel 152 pounds. Again, add the weights to find the total weight and add the moments to find the total moment. Divide the total moment by the total weight to find the center of gravity, 127 inches aft of the datum. In this example, our aircraft has a center of gravity range of 61.2 to 62 inches. The datum is located at the propeller spinner. Suppose we want to add an electrical system with a battery weighing 50 pounds and an alternator which weighs 8 pounds. Let's locate the battery at station 85, 85 inches to the right of the datum, and the alternator at station 26. The information on the aircraft documents is filled in on the chart. The empty weight of the aircraft is 609 pounds, and the empty weight center of gravity is at station 61.2. Multiplying, we find the empty weight moment is 37,270.8 pound-inches. The moment of the alternator is 208 pound-inches, and the moment of the battery is 4,250 pound-inches. Adding all of the weights, we have a total of 667 pounds. The total moment is 41,728.8 pound-inches. Divide the total moment by the total weight. The new center of gravity is at station 62.56. This is more than half an inch behind the acceptable CG range of the aircraft. To bring the center of gravity back to an acceptable location, we would either have to relocate the battery and/or the alternator, or install a certain amount of weight at a given point as ballast. The subject of ballast will be covered in the program on aircraft loading. Proper weight and balance is crucial to the safe operation of all aircraft. A review of the principles you've learned here and practice using the charts may be appropriate at this time. Take time to familiarize yourself with the information available on the type certificate data sheets, the aircraft specifications, and the aircraft listings. The safety of the flying public depends in large part on the ability of the professional aviation maintenance technician to properly calculate aircraft weight and balance figures.